All right, so let's take a look at 2.3.2 today. How can I make the data fit? So this is more graphing and scaling. In this lesson, you'll use all that you know about graphs to solve challenging graphing problems. Each of the situations in this lesson will require you to think hard about what a graph tells you and what the best way it is to show it. As you work together to solve these problems, think about what makes the task challenging. Focus with your team and how you can get yourselves unstuck if your teacher is not immediately available. Obviously, I'm not immediately available right now, so you're going to be thinking about these questions here. Does our data fit? Can we see it clearly? Okay, so if we move on to the first problem, it says Andre works in his family's juice shop. He has invented the new Mathberry Madness smoothie. Delicious. And word is getting around. He wants a graph showing how many new smoothies have been sold throughout the first month. He has gone through the cash register records and gathered the data for some of the first 12 days. And here they are shown in the table to the right. He wants to graph his data and use it to predict approximately how many Mathberry Madness smoothies he can expect to sell by day 20. He has started the graph below to the right. Okay, so here's the graph that he has created using this table right here. Obviously, we see the day that it is. So on the third day, he had sold this many smoothies. On the fourth day, he had sold this many smoothies by then. Go to the 12th day, he sold all the way up to 38 smoothies by then. So here is his graph to plot it. And as we look at this graph, we have to think about a few things. First off, can you use it to predict how many smoothies would be sold by day 20? Why or why not? So can we use this graph here to predict how many smoothies would be sold by day 20? What do you think? Well, do we have enough days down here? No, it ends at day 12, so we can't really make a prediction for day 20 without seeing 20 on this graph. So maybe we need to make our x-axis a little bit more spread out. So there's our why not, because we don't even see day 20 on the graph. And it says contribute your ideas to a team discussion and then work with your team to decide how to scale the axis so that you can graph Andre's data accurately. So now it's talking about scaling the graph. Remember, scale, what is that referring to? That keyword scale. Obviously, it's not talking about measuring our weight. Instead, scale here is talking about the intervals, the distance between each of these jumps. Now, when we're graphing, what do we know about scaling the axis? What do we know about all these numbers here? What do we want to be sure of? That they are in equal distance, right? Equal interval. And so here, if we're going from 3 to 4, we're going up 1. If we go from 4 to 6, we're going up 2. If we're going from 6 to 9, we're going up 3. Are we going up the same number each time? No, we're not. So here we're going to want to change that. And so we're going up by the same number each time. So what would maybe be a good interval to go up by each time? If we look at our new graph. All right, so now we have control. We get to put the days down here. We get to put the smoothies sold over here. Well, let's see, our data ranges from 3 to 12, but we want to go to day 20, so I have to consider that. So if I want to go to day 20 and I've got 1, 2, 3, 4, 5, 6, 7 jumps I want to make, well, I could do 20 divided by the number of jumps or intervals I have, which would be 7. And that'd be about 3, right? Because 21 divided by 7 would give me 3. And so here, I'm going to go up by 3s each time. All right, cool. Now we can fit all of our days on this graph, and they're spaced out evenly. They go up by 3. Now we're looking at the smoothies sold. That's going to be our y-axis. That's going to change based on our day, right? Smoothies sold depends on our day, so it's the dependent variable. And here, again, we have 7 intervals here, right? 1, 2, 3, 4, 5, 6, 7. And then our data ranges from 3, and then let's see, what might we go up to here? If we're at 38 by day 12, maybe we go up to like 100. So if I'm doing 100 divided by 7 to figure out how I can scale this, now we'll go up by 10s each time. That way I know I can fit all of my data. All right. And then if we were to plot these points, we're going to go 3 and where 3 would be on the y. I'm going to do these in green. So it'll be about right there. Now I'm looking at 4, 5. So I'm going to go to where I think 4 would be. It should be about right there. And then we're going to go up to 5. And we're going to go 6, 10. So I'm going over here to 6. And then I'm going up to 10. 9, 20. So I'm going over here to 9. And I'm going up to 20. 10 up to 28. So here's 10, go to about 28, right below 30. All right, so we could actually draw a line indicating our points right now. There's a little bit of a relationship, but not like a common increase, right? And so can we really predict what it would be at after 20 days? Not necessarily. However, we can make an educated guess. Let's go ahead and plot our final point here, 1238. And then let's try to draw our best line. This one's a little crooked and curved. So here I'm going to try to really get the trend of our graph. I would say once we get to day 20, which would be about right here, we'd be between 60 and 70 smoothies sold. That would be an educated guess. So you could say by day 20, which would be our X, 65 smoothies sold. You can't really make an accurate prediction. This is loosely based off of what we see here on our graph. All right, and then here we're going to be graphing data that we see off to the side. So first I want to figure out what my X and my Y is. So what's my independent variable, which is going to be my X, and what's my dependent variable, which is going to be my Y. In other words, what depends on what in this case. So here we're looking at the distance you travel. All right, so the distance that I'm traveling, obviously I get to decide on. So if I want to drive to Milwaukee, it's going to be, more like 120 miles versus if I drove to Madison, which would be 30 miles. So I get to choose the distance that I'm traveling. And so think about the I, an independent variable. I choose. So distance is going to be my independent variable, and that we're measuring in miles. And now we're looking at the traveling time. And this is going to be our dependent variable. It depends on where we decide to travel to, the distance we're going to go. And so minutes, that's dependent on distance. So it's going to be our dependent variable. Travel time. And we're measuring this in minutes. And so here, let's start off with our dependent variable in terms of scaling. So here, we start at 7, but we'll go ahead and start at 0 because it's not too far off, okay? So we're going from 0 to a maximum of 20. All right, and so there's a difference of 20 there. So I'm going to go 0, and then what I want my next one to be, if this whole thing is going to be 20. How many spaces do I have? Well, I have 1, 2, 3, 4, 5. So I could do 20 divided by 5, and that's going to give me 4. But instead of going up by 4s, I'm just going to go up by 5s because that might make my data a little bit easier to graph. 5, 10, 15, 20, 25. Nice. And now I'm going to graph my independent variable for scaling. So I'm looking here in red. Here we're going from 0 to 5. And since we have 5 spaces, we'll just go up by 1s. So 0, 1, 2, 3, 4, 5. Notice we do have some decimals, but that won't bother us too much. We just know to put the decimals in between those whole numbers we see. And so let's start off by doing this first point in green. We're going to go 4.1 and 13. So I'm going to go over here to 4.1, which would be about right here. And then I'm going to go up to 13, which would be just below the 15. So there's my first point. My next point, I'm going over on my x, my independent variable axis, to 1.7. So that's going to be over here, right between 1 and 2, more towards 2. And then I'm going to go up to 7. And so if I go up to 7, that's going to be about right here. And then going 3 over, up 10. So again, over 3, up to 10. And then 2.2 and 20. 2.2 would be between 2 and 3, more towards 2, up to 20, all the way up here. And then finally, 0.5 and 9. So 0.5 is going to be halfway between 0 and 1. And then if we're going up to 9, it'd be just below 10. So there's our points. Obviously, we're paying attention to not the points on the x, we're paying attention to the points on the graph. And if we wanted to draw a line connecting our data, we could do that. Call this a line graph. All right. So here I would explain that I created this graph. I scaled it by 1s on the bottom so we can see the growth from 0 to 4.1, and I scaled it by 5s for my y because we're ranging from 0 to 20. And I would say that this does show a relationship between the distance that I travel and the time that it takes to a certain extent. I mean, it's not very clear. We slowly, and when I say slowly, like we very slowly make our way up here. And it's not super clear because when we travel 2.2 miles, we go, it takes us 20 minutes. And then when we travel something like 3 miles, it only takes us 10 minutes. So there wouldn't be a correlation between these 2 points, but there's somewhat of a trend here on this graph, just barely, but not enough to say that this like tells us for sure that as you increase the distance, it increases the time. All right, let's do another one here. So this one is part B, and it says the number of visits and the cost in dollars. And so let's go ahead and take a look at what our x and y is. So what depends on what? Remember, our y is going to be our dependent variable, thing that depends on the other, and then our x, that's going to be our independent variable. So what we adjust, what I decide to change. Think about that, I and independent. So here we're looking at what I would change or have an impact on. Well, I could kind of influence the number of visits, right? If I am a good employee, for example. So the number of visits is going to be a changing number. All right, that's going to be my independent variable. And then what's dependent on the number of visits is going to be my dependent variable here, right? My cost in dollars. So that's going to go over here. And then let's see, we go from 50 to 150. That's our range. So I'm going to say we go up by 50 each time. Because if I do 150 divided by however many intervals I have, it's giving me about 30. but I like to go up by 50s and 100s and nice even numbers like that. And then I'm looking at, what about my number of visits? So here I'm going from 18 to 114. We'll say 0 to 120 to be safe. And so I'm dividing that by 1, 2, 3, 4, 5, 6 places. So 120 divided by 6. That's going to give me 20. So here we're going to go up by 20 each time. And if you decide to go up by something like 50, that also works as well. This is just what I'm choosing to do here. Good. You can fit most of our data points there. Good. And so now we're looking at where our first point would be. So let's go ahead and start graphing. We'll do that in yellow. So here we're going to go 18 over, and then we're going to go up to 53. So it'll be right above 50. And then we're going to go 29 over, and then we're going to go up to 65. Then we're going to go 100 over, and then we're going to go up to 135. 84, 119, so 84 would be about right there. 119 would be about right here. Maybe I could have made my y's a little bit more spaced out. That could be a mistake that I've made here in my graphing. 62 would be right past 60, and we go up to 97, just under the 100. And then 114 and 149. So here I'm going to 114, which would be about right here. I'm going up to 149, right underneath the 150. So here we see a little bit more of a correlation, because notice we do go up each time, right? We go up a little bit in cost based on the number of visitors. So there's definitely a correlation there. Now it's not a drastic correlation, right? It's not going like way up like that, but it is still going up. So there's definitely more of a correlation or relationship in this case compared to this past graph that we looked at. All right. So then you guys are going to be looking at this problem here, 2-127, and this is referring to baseball. And Jackson, he created a data table based off of the pitcher's height and the year of baseball that he was looking at. And so in 1870, for example, the average height of a pitcher was 69.3 inches tall. And then for some reason, you know, the pitchers just got taller and taller, probably because they were bigger and stronger athletes that they desired over time. And so in 2000, for example, a pitcher's height had increased from 69.3 inches to 74 inches and had gone up 5 inches since 1870. And maybe we are just getting taller as humans. That could very well be. And so now we're going to try to create a graph using this data here. But you'll find that when we try to graph this out, you know, it's kind of tough because for one, we have decimals here, right? And also we have numbers that are very close together. In other words, yeah, 69 is a big number, but 69 is so close to 74. And so what we might want to do is what Jackson decided to do for part D, and that is spread out the data more by starting with 1870. Does that make sense? So instead of, you know, going from 0 to 1,000 to 2,000, we're essentially putting a break into our graph, and we're going to start with 1870. And then our next one up would be 1900, and then 1930, 1960, 1990, and then 2020. Hey, look at that. And then we could fit all of our years on there and our data would be more spread out. We could do the same thing for the height. So instead of starting at 0, 10, 20, and all these being blank down here because we don't have any data until we hit 69 inches, then we could go ahead and actually start at 69. Now, typically, you would have a break in your graph because you always want to start at 0. And so you'd say I'm going from 0 to 1870 right away and 0 to 69 right away. And then we could do the same thing where we just go up by 1 each time here because we could fit all of our data just about if we went up by 1 each time. If there's going to be one, or two of them that we plot off the points, the 74.3 and 74.4, they would be just past 74. But this data would be much easier to plot if we had a graph that looks like this. So we call this a good graph as far as the setup goes, and we just have to plot the points. But we've done a lot of plotting so far, so I will leave you guys to that. All right, here we're looking at the methods and meanings math notes. And this is about intervals and scaling. So the numbers on the axis of a graph show the scaling of the axis. The difference between consecutive markings tells the size of the interval. So again, the interval is going to be the space in between each mark here. All right, you basically think of space and interval as the same thing. When you scale each axis, you must use equal intervals, keyword equal intervals, so go up by the same each time. We can't jump from like 3 to 5 to 21. We have to go up by the same each time. For example, an interval of 5 creates a scale numbered 0, 5, 10, 5, 15, etc. Unequal intervals distort the relationship in the data. It is important to note that horizontal and vertical axes do not need the same scaling. For example, here we went from 1870 to 2020, and then we also went 69 to 74 for the x-axis. So a difference of 30 for y and a difference of going up by 1 for x. Notice on the graph at the right that 80 marks the end of the fourth interval. So here we see 80 as our final interval, and so we can use that information to figure out what the rest of the intervals would be by simply doing 80 divided by my number of spaces, which is 4, and that gives me 20. So I know to go up by 20 each time. That would be a good way to scale my axis. All right, so hopefully you feel like you have a better understanding. Some of these are kind of tough to graph, and that's kind of the whole idea. It's involving a lot of thinking to figure out how you want to scale your graphs. All right, but basically it's just a way of putting the data somewhere where you can see it very clearly and quickly, and judge right away if there's a relationship, for example, between the day it is and the number of smoothies sold. All right, so good luck with your homework. Please make sure you turn in these core problems and join the Zoom at 1 p.m. Thank you very much.